All right, in the last video, you looked at inequalities and graphing those inequalities and how that looks with numbers. Now we're going to look at word problems. How does this look like in real life? Because, again, nobody's going to come up to you and say, C is greater than or equal to 2.5, graph it. That would be strange. However, we will see inequalities in real life. So we're going to look at what language we're going to see and how that looks in a real world situation. So no more than, if you see that term in a word problem, no more than, I can have no more than 5 students in my class. That means I can't have more than 5, right? I can't have 6, I can't have 7, I can have no more than 5. But I could have 5. No more than 5 students means 5 would work, or 4, or 3. So less than or equal to is what no more than means. At least. I need to make at least $50 this weekend. Babysitting. That'd be a lot of babysitting. But I need to make at least $50 this weekend babysitting. That means if I made $52, that would work. That'd be at least 50. If I made exactly 50, I would make at least 50. But anything less than that, 48, 45, $30 would not be enough. So at least means greater than or equal to. Ray's dad. Ray is in my first period, but Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees. So to define a variable, I don't know, we're talking about temperature, right? Let's go with T. You can use whatever variable you want. I'm going to define the variable. I'm going to say T. I'm going to define it. T means temperature. There we go. So T means temperature. I'm going to define that variable, and that is important that you actually follow the directions. If the problem says define a variable, you have to tell me what the variable means. T means temperature. If you had used X, that'd be fine too. X means temperature. If you had said smiley face means temperature. Actually, I'm going to go with smiley face. Why not? That's more fun. So smiley face means temperature. And I'm going to write an inequality for this temperature, which Ray can turn on the air conditioner. At least, it says. I underlined that. At least. Let's go back. No more than, no. At least. At least means greater than or equal to. Ray's dad told him not to turn on the air conditioner unless the temperature is greater than or equal to, unless the temperature is greater than or equal to 85 degrees. So I'm gonna rewrite that. Unless the temp is greater than or equal to 85 degrees. So again, all I did was I took the sentence that's already up here, or the part of a sentence, unless the temperature is at least 85 degrees, and instead of at least, I replaced it with greater than or equal to. That's all I've done. Okay, so here, the temp. The temp, we don't know, but I've defined the temperature as being smiley face. Here's my variable. Is greater than or equal to 85 degrees. There we go. I've written an inequality for the temperatures at which Ray can turn on the air conditioner. When you're looking at these problems, the inequality is spelled out exactly the way it needs to be written. Unless the temperature is at least 85 degrees. The temperature we defined as smiley face. At least means greater than or equal to. 85 is 85. I've got my inequality. Now I'm going to graph my inequality. For a variable just is a symbol that represents an unknown. So it doesn't matter what letter or what symbol you have. Maybe don't use a times or a plus symbol. That might be confusing. But smiley face is greater than or equal to 85. So 85 is my solution. I'm going to put that in the middle. Again, why not? I'm going to count by sixes or by ones. This is where, and maybe I should stop. This is where counting by hundreds maybe wouldn't be the best, because your house is probably not going to get up to 285 degrees. And so in a real world situation, 285 is probably not a legitimate or a reasonable, maybe a reasonable scale. By ones will work just fine, however. So with real world situations, you have to be a little more careful with your numbers. Okay, smiley face is greater than or equal to 85. So 86 would be okay. 87 would be okay. And 85 exactly would be okay. I've defined a variable, smiley face, temperature. I've written an inequality, smiley face is greater than or equal to 85, and I've graphed it. Okay, we did it. Try another one. I'll spend a little less time explaining it though. Stores employees earn at least, there's that word again, that term, at least $8.50 per hour. Define a variable, I don't know, how about lightning bolt? Lightning bolt. Lightning bolt. Lightning bolt means what? Well, what am I talking about here? An employee earns their earnings. So let's go with earnings, which is different than earnee. So earnings. So lightning bolt means their earnings. That's how much they earned. So their earnings is at least $8.50 per hour. So if they made $9 an hour, they'd probably be happy. If they made $20 an hour, they'd be happy. If they made $5 an hour, not so happy. So the store's employees earn at least $8.50 an hour. So lightning bolt is greater than or equal to $8.50 because they could earn exactly $8.50 and be okay. More than $8.50 is even better. But less than $8.50 is not acceptable. Now I'm going to graph it. 1, 2, 3, 4, 5. And let's see, $8.50. Again, if you went up by 50s, they're probably not going to get paid $58.50. So pick a scale that's appropriate. Because I'm stuck on going up by ones for whatever reason, I'm going to stick with ones. $7.50 and $6.50. If you went up by 50 cents, that would be a very legitimate way of doing it. If you went up by a penny, that would be fine too, but probably not by 50s. All right, so I've got my numbers written in. Lightning bolt is greater than or equal to $8.50, so anything more than $8.50 is fine, and $8.50 on the dot. Hey, on the dot, it's a colored in dot, would work as well. Okay. Well, you know what? That's going to be your assignment, and we'll talk in class.